Okay, recording started. Now we'll try to go those slides. Electron theory. Oh, we discussed those things. So I'm difference. Okay, I can start from here also. So I don't know if the system people are, I don't know that they know or not. They don't know. If they can come up, it will be better for them because they can learn something from this demonstration. So this is how you can see also. This is.
You guys have a couple minutes to come up to the war room.
This is a picture of
Donald and Ariane.
The control box for CDMS.
Yeah, sure.
And you saw all those markings here in the cable.
They're on their way up.
Yes, if they come, no problem. This is the actual thing in the cabinet, inside the cabinet. But when you see the schematic diagram, this is not same thing as you see in this picture. Because if you don't understand those schematic drawing like this, it represents that one. Basically, this represents that one. So if some people don't understand those schematic drawing, if they go in the field, they cannot correspond this drawing with the practical with the physical drawing, physical thing. So that's why I believe that we need to understand those.
Here's a question for you. When we look at the fiber diagrams,
yes,
they have different colors. When, for example, we're putting out a project like the other one that you guys are working on now, everything's going to be in black and white. How do you differentiate among those different colors? In other words, if I'm looking at the plain sheet,
okay, yes.
everything is going to be black and white.
Yeah, everything is black and white, but we can understand those things. The fiber thing, if you see in the
fiber, which has multiple colors.
Yes, if you see in the fiber drawing that it is written in each fiber, they write blue/blue, blue/orange. That means first one is the blue tube, and next color is in the drawing. If it is black and white, they always write this way: blue/blue, blue/orange, blue/green. That means first one is the tube, next one is the fiber strand. And same thing for next, they go green/blue. That means first one is the tube, next one is the strand.
Okay, so how many people here have seen a fiber tube?
Yes. I've seen one, but I didn't know it. Real fiber in real life?
Yes, real life.
I feel like the samples and stuff like that. I'm not in the field.
Yes.
I think,
so how many people know that how many fibers reside in one tube? In one tube, how many fibers there is? In one tube. You saw the tube. You are telling, yeah, it is good. You saw, everybody sees the tube.
12?
Yes. So you need to know these ones.
I guess it's 12 because it's usually in multiple of 12.
So yeah. As you asked, everybody there saw.
Could you make a presentation as part of your presentation, maybe next time?
Yes.
Actual fibers, so people can understand what.
Yes, this is very. I'm telling you a practical thing with Giselle. Giselle never thought that fiber comes this way and go. She thought that it is like twisting as physical cable. When you twist to, she always think that way. She said, why it coming here and then I said, no, Giselle, it comes from the back. It comes from this way. She said, oh my God. I totally think that this comes and joined like this. I said, no, this is not the physical cable thing, fiber thing. Yeah, you are right. If people know everything practically, how it is going on, how it is marked, it will be better for them to understand the drawing, and also when they think about that connecting those fiber, if they instruct the field team, you will more understand clearly that you do that way, and the fiber is coming this way. And same issue we faced in Springwood Parkway recently. You know, every fiber is two fiber. One is transmit, one is receive. But in a Springbrook connection, we have one fiber doing transmit and receive. People don't know. When my field team go, they thought everybody think that way. This is the usual thing. One transmit, one receive. And they connect, or no data, no nothing is happening. This is why. Oh, I'm telling that in Springbrook fiber, the design is little different.
So,
One fiber giving you the transmit and receive.
so with the LHTL, as we're getting this fiber from the two-way, and we talk about the two fiber, does that mean one
Yes.
is for the
Transmit,
transmitting?
yes, one is receive. And same thing happening when they connect switches with router or whatever it is. There is one pair of connection which goes transmit and receive. And I will discuss, they will discuss later on the crossover cable and straight through cable. What is the difference between when you talk with switch to switch, what kind of cable you use, and there is a 2 pin. I believe number 3 or 4 is transmit and receive. If it is not accurately matching, you are connecting the cable because they are manufactured they're manufactured that way. When you manufacture, you have to know that, okay, this is transmit and this is receive. And that's why the straight through cable and cross wire connection cable, there is a little different. When you connect computer to a router, I believe you have to use the crossover. Why? They'll explain later those things. If you know those basic, it is very important. And when you know the basic, you know that how we are connecting individual wire internally. This is very important. Okay. Next, once we will try to take the class for the fiber also, because we have some equipment and OTDR something. I don't know total the OTDR, but I believe Sujit has a training. He can explain something with the OTDR. Otherwise, I bring EJ people. Nelson, he's a very good technician, fiber technician. He can explain you the fiber trace, how it shows, where the splice is. If you see this thing, how you understand that this is splice, it is very important for everybody. So knowledge is always good, and what we are doing, if we know those things, it will be better. Okay, so now they are here. System.
All here.
The team is not here. The field team. Field team is important also. They forgot again. Try to call them also. This is important. If
Let me see if I can get a hold of
this for them actually. So I'm telling those things. See, this is the actual picture in the PVMS box. The PVMS what we are using. The box is like this. So what is modem? The connection is here. Mostly we are facing difficulties with many projects. They developed a box, everything they connect. That do not do these things. See, every wire is marking. See, 49, 43, 49, 48, 47. And here also you see each wire which comes from outside or internally, they are properly. See, two-way, and every device is fused and it is 10 mm. Everything is marked on the, okay. And TV, you see, TV, this means terminal block, TV 5, TV 4. Why they mark those things? Because these, you have to correspond this box with your schematic drawing. If you see in the schematic drawing, it's not same like this. It is different thing. Okay. And if this marking is not properly labeled in your box, you cannot read the drawing properly in the schematic drawing. And in most of our project, the converter do not do properly this thing. And we face difficulties. They say, oh, you can say, yes, we know few were, but if you write everything clearly here in your schematic drawing, it is easy for the maintenance and easy for everybody. So
in this case, these wires, that's for electricity, right?
yes. So no, here 2 wire is from solar, 2 wire is from battery, and this is the battery cable actually. It is coming in the solar controller. This is solar controller. It is coming in this box, and this output goes to the controller. This is the solar controller actually. And this is for when you want to charge these batteries externally from the AC. This is the charge controller. This is, you do not need the when it is operating in the solar. But when you want to charge those things, you have to plug in this with the AC, and it will charge the battery from here. And in other case, only this solar controller will charge the battery. Only for AC, you will use that one. This one is the AC. And also, you know that, there is also rating of this thing. That's why everybody understands that what is amps, what is, if you use 10 amps, charger, it will take huge time to charge the battery. If you use 100 amps charger, it will take less time because you are pushing, charging externally with 100 amps. If you use 10 amps, how long it takes? 10 times more. That means 10 hours. If it takes 1 hour with 100 amps to charge the battery, if you use 10 amp charger, you need 10 hours. That's why the charger rating is also important. So this is all those technical things everybody has to know who works in the field. Yes.
That's a basic question. Your red and black coming from just below where the terminal, well, I now know it's a terminal.
Mm-hmm.
Okay, that's going to the, all right, and that there's a spot there, is that splitting into two?
Yes.
Below,
Yes.
just right below that,
Yes.
right here, yeah.
Yes.
Okay, and then that's splitting to that up there, and
Yes.
that's,
You see, one is coming from the charger.
okay,
Yes. When you
okay,
use
and then where's the other one
yes,
going?
you understand those things clearly when you can read the schematic drawing. From here, it is very difficult. How you can read where it is going?
Yeah.
And that's why physical thing, you need some physical thing, you need a schematic drawing also. Because you have to trace this where it is going here to here. And that's why we create, we create this. Okay, I stop it. I'll go by normal presentation. Okay, this is a schematic drawing. Why it is going? It is automatic. Where is the mouse? Yeah, here.
To the screen,
Okay, I cannot see here. Oh, it is double screen, that's why. Yeah, it extended. Yes, that's why. Okay, so I better go from slide to slide here. It'll be easier. Okay. So,
Did you already pass all
yes.
the slides?
Yes, so last time we
That was last week, right?
So when you have this schematic drawing, it will be easy to interpret. I'll show you how it is connected as Randolph told. See, this is the charger, and charger cable is how goes. It shows here. See, the connector is here, and it is connecting here, and it is connecting here. Everything you can trace from your schematic drawing, but physical drawing you cannot. And if you do not mark every individual cable with the marking, say 401, 402, if you don't mark those things, you cannot correspond this cable with your physical thing. So that's why marking is very important, but people don't do always the marking thing. And everything will be labeled properly. See, if I say TB5, you saw the TB5 in the previous slide. So, see TB, I show you where TB5, suppose. Where is TB5? And I'll show you in the next drawing. See, if you see here, it is looking at TB4 or TB5, this one. See, physical and schematic is huge difference. It is not like the same thing what you see in the schematic drawing and as you see in your physical thing. Here, you see TB5 is different than what you saw in your physical case. The controller is here and the charger is here, but in the physical case, both are on top of each other. You see, it is not like this. Here it is here and here. In the drawing, it is one is here, one is there. So physical drawing and a schematic drawing is not the same thing. You have to understand the physical and you have to understand the schematic also. So if people can work without knowing all those stuff. Work means he cannot do proper work in the field or if he don't understand those drawings properly. And this is a great challenge sometimes comes to me also when the new maintenance contract come, and if they do not have good crew, I believe in our region also, how many ITS team you have good team. So for EJ, this time I face very difficulties that they do not have good crews. All are electricians, but they don't know ITS thing. They cannot read this drawing. They do not know how to interpret this drawing with the people. It is a huge thing. But anyway, when somebody like Mike Kish, he goes from our team to EJ, now he's helping us a lot actually. He knows really good regarding those electronics and electrical part. So this is the schematic drawing, this is the physical drawing. Then we'll see the Ohm's law, very important. Here, who is here from the field team, this law is very important. You need to know this thing, and what we are doing the calculation, what Hassan is telling that, okay, power calculation, how much amps, this law is simple, and you can always calculate simply on your head also. If somebody say, Evan, oh, this is not working, how much watt is there? You can easily calculate how much amps you will need it. See, this is the formula, Ohm's law. This is the basic law for the electrical engineering or electrical people or electrician. It is called that Ohm's law is Simon's Ohm, George Simon's Ohm, which is a German engineer and mathematician, I believe. He developed this law. And the thing is, voltage is proportional to current. Okay. I'll show you, but I have a draw board actually. If I bring that one, I can show you in the board also. Voltage is proportional to current. That means directly proportional. There is two proportional. One is called directly proportional, one inversely proportional. Directly proportional means when you increase this one, these will increase also at the same time. It is called direct proportional. And inverse proportional means when you increase one and another one decrease at the same time. So voltage is proportional to current. That means what it means? When you increase the voltage, at the same time current will increase. Okay? Voltage is voltage proportional to current. When you increase the voltage, at the same time the current will increase. When you lower the voltage, and that's why it was happening. LVD. LVD is why? Because low voltage. When the voltage goes low, the current will increase and the breaker trips. Why? The breaker is some rating, 10 amps suppose. It can take 10 amps. Now voltage decreases. That means current is decreases also. So when voltage increases and current, okay, I'll explain this thing with the R later. So when voltage increases, current increases. When voltage decreases, current, it is vice versa. And when you make it equal, V equal to IR. Proportional, when you make any proportional equal, you have to put a constant. That is the resistance actually in that case. So the R, V and I, this three term is very important for us, and when we calculate our devices, we use this formula in every cases, But you have wattage also, wattage, voltage, I'll show you later. Watt and voltage, this is important also. If you know the watt, if you know the voltage, you can calculate the current, and if you know the voltage and watt, you can also calculate, if you know the current, if you know the watt, you can calculate the voltage also. So, see this formula, V equal to IR. Any place, if you see current, if you see voltage, you can calculate this one, okay? And yes, there is a simple question regarding those. It is called voltmeter. When you use voltmeter, you have to measure the voltage across the terminal of the battery or across the terminal of a current source. Across means in 2 points, in positive and negative. But when you measure the current, you have to put the in series. In series means, okay, when wire is going, you have to cut the wire, you put the meter, then you can measure the current. For voltage, you have to put across. Across means one terminal, positive, negative, or whatever it is, across between two lines. When you measure the current, you have to cut the wire and you have to put the meter. Otherwise, you cannot measure the current. So, in that case, how we can measure current if physical wire I cannot cut? we use the clamp meter. You know everybody clamp meter. You use the clamp meter. Clamp meter means there is another. I'll show you later in my slides how it works. Clamp meter, when you put the clamping, you cannot cut every time where to put the ammeter in series. So I told you that when you put to measure the current, you have to cut the wire and you have to put in series with this cable for measuring the current. In that case, we use clamp meter. When you put the clamp meter like this way, you don't have to cut and it shows you the actual reading of the current, what is going in the circuit. Okay? And voltage you can easily measure. You don't need a clamp meter. You need just only 2 points, put there and it shows you the voltage. And there is a calculation, how you calculate. If you know the voltage, if you know the resistance, you can calculate the current easily. So the voltage is here 10 volts, the resistance is, and this is this simple thing. You don't need to know that thing, just you know the formula, V equal to IR. Know this formula, if they give you voltage, they give you resistance, you can easily calculate the I. This is simple thing. But the thing is, you have to know this is the important thing for here. If I tell you to measure the voltage, you go across. And in the field, when I tell you that measure the, and there is two different current and voltage also. One is AC and one is DC. If you go in the field, if you measure, there is a pointer in your meter, it is called multimeter, and you have to point those things in the AC or DC. If you do not put the pointer in right point, you cannot measure the voltage or current properly. Because you are measuring DC. Now you put if you put your pointer in the AC, you cannot get the result. And also you are measuring the AC current, you put in the DC. No. Okay. And there is symbol also, DC and AC. If you see in your meter, the one like this wave thing, it is called AC. And if it is two line, straight line, it is the symbol of the DC. So this simple thing you have to know. Each time you will use the meter or you interpret any drawing, you have to know those things. And this is another circuit, another thing. I'm not going detail of all those things. This is the basic thing. Basic, you don't know, you do not need this stuff in your practical life. Series. What is series means? If you connect one by one, tail to head, then it's called series circuit. So basically, for our case, we don't need this thing. Just you need to know that series is one head to tail, and parallel means from one top to tail will group together this way. This is called parallel. You don't need those. Okay, this is very important now. AC and DC. So other part is not that important for you. For electrical engineer or who do the calculations, they need to do those things for designing or something. AC and DC. So you know the trigonometry, the sine, cos, tangent. We need those things. And where we implement those? We actually practically, as an electrical engineer, we implement those functions, trigonometry function, in each case in our daily life. Sine wave. What we are seeing here are a sine wave. Basically, the current is going this way. The current is going this way. So it is a one cycle. And you know that our frequency, US frequency is 60 Hertz. Okay. When one wave goes this way in 1 second, one wave goes in 1 second, it's a 1 Hertz. That means it goes from 0, go top, go again bottom, minus, and then comes 0. 1 second is 1 Hertz. Okay, our frequency is 60 cycle or 60 Hertz. That means in 1 second it jumping 60 times. 60 times it is happening in our power frequency. 60 times it is jumping like this way. And you know the speed of the computer clock or whatever it is, how much? Gigahertz. How much is speed? Can you imagine those things? See, gigahertz in 1 second. Giga means okay. Kilohertz. 1 kilohertz means in 1 second it is jumping 1,000 times.
Giga is 1 million.
And yes, giga is 1 million. And mega is?
No, mega is 1
No, mega is million. 10 to the 6. Mega is million. So kilo is 1 kilohertz means in 1 second it's jumping like this way 1,000 times. In megahertz means it is jumping 1 million times in 1 second. Gigahertz means what is it doing now? Can you imagine those things? If that kind of jumping happened in your clock internally, in your processor, what happens? If you jump, you will feel, okay, you become hot. That's why you use fan actually in the computer and other stuff or any electronic device, you see a fan. Why? It becomes hot. Why it become hot? Because it is actually functioning huge speed. Okay, so this is the AC. Our current is 60 hertz. That means each time it is going like this way. And if you see here, from 0, it goes up. Up means how much up it goes? What is our voltage here? 110 volts. You know, everybody, the power is 110 volts. That means our power starts from 0, it raised 110 volts, again comes to 0, and in negative portion it goes again, minus 110 volts, again comes to 0. So in one cycle, you see, one time it go peak and lower peak, and peak to peak, how much voltage? 110. Peak to peak. If you measure peak to peak, the peak to peak is 220 actually. Peak to peak voltage. And in one cycle, it is going up, down, so it is every time the power is going 0, 0, 0. In some period of time, it is going to 0. There is no current actually, or no voltage. And in 60 hertz hour cycle, 120 times the light is actually going off, on, blinking. So you say, why I cannot say blinking? Because, yeah, you can say it. Why?
Because we have a frequency of 60 hertz, it will fluctuate to 60 times within 1 second. So it's like 1 inverse of the hertz, and the unit is a second. So 0.016 seconds, it will switch.
It is blinking. It is blinking every time actually.
In 1 second, it will switch.
Yeah. No, I'm explaining those things. Why normalize? Okay. You know everybody that persistence of vision. I don't know. Everybody learn those things. Persistent vision means when you see something, our retina can keep this vision for 1/10 of second of a time. It can create. If you see something, it will stay in your retina, in your I say the window or here it stay for 1/10 of a second. Okay, if you do not show them again in 1/10 of a second, you cannot see this thing. Okay, if in between, okay, suppose I am showing you this thing. I again circulate here, I bring it here before 1/10 of a second. You will see this thing is steady. Why? Already it is staying here for 1/10 seconds. You bring it again, but if you bring it later, you will see, oh, it is coming tick, tick. You will see tick, tick. If you bring it in between 1/10 seconds, you will see this one is steady, but it is not steady. I bring it before 1/10, but it is moving. Why you think it's steady? Because it already retained this thing for 1/10 seconds. I believe you understand that thing. Because, okay, suppose your retina, okay, sitting here, it stays something for 10 seconds. It can hold. Okay, you show something here, see, and hold this thing for 10 seconds. Okay, you bring it at 11 seconds. What do you see? When your eye, after 10 seconds, it vanished. You see nothing, because it doesn't come here between 10 seconds. Okay, what happened? 10 seconds you can catch it. Okay, you bring it in 9 seconds. You round it, but it will see this steady because it already retained this thing for 10 seconds, and you bring it again within 9 seconds. So it's see it as steady. That's why we see it steady light, not like blinking. Anybody? Yeah.
Fan, right? You see the window fan.
Oh yeah, fan. The blade.
So you see the.
Yeah, you see blade. Blade is all. You see, there is a revolving, but blade is not always every place. Some place here, sometime here. But when you see revolving fan, it's the it is solid. It is solid ring. Same thing with the iron bar. If you move it like this, you see a ring of, and this is called AC. And now I am telling you the single phase and three phase also at the same time. So this AC sine wave and our thing is there. For battery, what is the difference between AC and DC? Now I am telling you. This is AC is like wave, but DC is steady. It is not like wave. And in DC, there is no frequency. DC voltage is steady. Steady means it always go. Zero is zero. That means black wire. And positive always go steady like this. The graph is steady. It's not jumping anytime. It is always steady. DC. I didn't bring the board today. Writing board. You learn something very good thing. What is inverter? How inverter works? It's a simple point, but even though I'm showing you something, no problem. So it's steady thing. So DC is steady. AC is jumping. Okay. When you try to convert DC to AC, DC to AC. Suppose it is going steady now. So 12 volts. You want to make it yourself, DC, AC. What you can do? You can take a probe, you can touch it with the ground, take it out for 2 seconds, touch it again ground, take it. What will happen? The DC will be, sometimes because you're positive, you go to grounding, zero. So if you make it 60 hertz, you can create from DC to AC. Simple thing. And in the inverter, they do it that way. In inverter, the DC, you feed the DC, there is circuit, electronic circuit, it blink in particular time, and it gives you the AC. Okay, and you can say, okay, DC is not like going this way. When you do 0 plus 0 and off on, the wave is not like this. This is square wave, square. And this is called sine wave, that one is not sine wave. So how you can make square wave? Square wave is a combination of multiple sine waves. We learned those things in Formula Fourier series. We have to analyze those things in engineering. See, many multiple frequency can make square wave. Square is a combination of. That's why you will hear sometimes harmonics in the power frequency. Harmonics, those comes play important role in the power distribution system. The harmonics. Okay, this is the big thing, but simply know that this is AC, DC is steady. So this is pulsing. That means, so DC is very dangerous than AC. Why? AC is sometimes going to zero. When you shocked, it sometimes goes zero. But DC is steady and it will burn your heart also. If you pass only 3 volts like this way from year to year, you will die. But if you pass 50 volt AC from year to year, you will not die. Because it is jumping and your heart also jumping. Okay, we'll see it later, but this is the simple thing I'm telling you. We can explain this thing more detail. This is AC and okay. Now you see this is sine wave. Okay, why you see sine wave? I'm telling you a little bit. It is a little extra, but sine means when you something starts from main line. It is y-axis, x-axis. From 0, it goes sine. If I shift the axis to here, I shift this one here, it starts from 90. Then it's called cos wave. Cos is shifted from sine 90 degrees. It is geometry. But there is cos wave also, sine wave. But cos and sine are basically the same thing, just shifting of this thing. And when you are seeing this is voltage. I told you this is the sine wave for the voltage. So what is the current? Current also goes sine wave, and current doesn't go follow same way as voltage. The current wave shifted little bit with the y due to inductance resistance. The current wave is not that high. Current is little less, and it goes. Suppose voltage starts from here, current starts from here, or current starts from here also. So, front or behind, it is started. When there is a resistive element, resistance, the current starts with the voltage same way. That means when voltage starts from here, current starts from here, but little less like this. If it is not resistance, if this coil or inductance, then current started not the voltage same way. It shifted up. We call this lagging or leading. And that's why when you run motors in your house or some plant, you see when you start the motor, it blinks your light a little bit. Okay.
Is it lagging at the same frequency or?
Frequency same, yes, yes, yeah, you are right. Frequency is same, but it is started little down or up. For capacitor, it is started behind. It is not that important, but just for general information I am telling you. Okay, for resistive element, always started the same way. When voltage is from zero, current also started zero. In normal case, in our residential use, we always think our devices are resistive. That means current starts with the voltage. If current starts with the lagging or leading, there is a huge penalty come from the power authority. Because this is the best. I'll show you later those more things, how factor difference is a big issue with those voltage and current. But generally, the angle between current and voltage, this is very important term. Everybody should know. We say power factor. Power factor plays very important role in power system. Power factor is the cause angle between voltage and current. If we can say power factor 0.9, that means 0.9 means what is the angle of the 0.9? Maybe 13 degree or 10 degree, whatever it is cause. So when you take the angle between current and voltage and you put in the calculator cos angle 60, 30, this is called power factor. Power factor is very important. When somebody say power factor, in every device is written there, power factor. For resistive element, there is no angle between voltage and current. That means their angle, voltage and current is zero. Zero. Angle between voltage and current for the resistive element, I told you, zero. So cos 0 equal to 1. When you see power factor 1, that means this is resistive element. Cos 0, always 1. If you put cos 0 angle in calculator, you see 1. That means power factor is 1. Power factor 1 is a very good thing. We always try to keep everything 1 and close to 1. Close to 1 is always good for the power authority. If it is goes 0.75, it is a big problem for them. Okay. And I'm not going that detail for those basic, but just learn those things. Everything what we are using, we use power factor 1, cos 1. Power factor means cos theta. Cos theta means cos angle between voltage and current. Just this is very important term for technician, I believe, but many technicians don't know this thing. So what I told you here, it is single phase voltage, not current. I'm telling always voltage, same thing. If you think current also same as Randolph mentioned, frequency is same, everything same. Only difference is the amplitude. Amplitude means the width. It is voltage is going 110 volts, maybe current go less, very less. It is less amplitude current. But so this is the voltage wave, and what you see here is our voltage, and it is single phase actually. Single phase means what is between single phase and three phase. Now I am telling something. So in another picture, you see the voltage, 3 voltage is there, and it is called three phase. So mostly in our case here we use single phase, 240 voltage or 110 voltage.
In reality, how is that produced?
Okay, I'm telling you, in reality how, yeah. I have those, here also, the drawing is here also, yes, how we produce, yeah, I know, you see, yes, here. I'm coming there shortly, how it produce. I'm not taking how much, I'll not give you, yeah, so we'll finish it 1 or 1.5 minutes is better. If we say something more, you cannot take all those things, information, it is better, and we have other things to do also. Okay, if you enjoy, I can carry on, but everybody has to do something. Okay, so this is three-phase. Three-phase. So just look at this drawing, very important. See, one starts from 1, these go this way, from 0, 1, 1. Another starts from, see, little shifted. And another starts from here. See, there is a three waves. One wave is this, one wave is this, and another wave is this. There is a shifting between three waves. So, in three-phase system, there is a phase shift. Phase shift means angle difference. One wave to another wave is 120 degrees. Just remember it. 120 degrees. Why 120 degrees? If you make a circle, how much degrees is one?
360.
360. If you take three equal space, how much it will come?
20.
120. So, in voltage cages, three-phase, there is a difference between phase shift is 120 degrees. B, C phase, three-phase, there is a shift. Okay, then you say, okay, if it is different, if you say, take one phase, first phase, you turn on a light, it will turn on. Okay, take off this thing and you put another phase. Same thing happens. The light will understand that this is A phase, B phase, C phase. And all are same. If you see here to ground, 110 voltage. From here to here, 110. So what is the between three phase? When you try to connect this phase with this phase, is spark. Okay. If you take two wires from same phase, you take two wires, you don't know that they are phase or not. If you connect those things, they will not spark. Because they are same. But when you take two phase, it looks, in your meter, it looks same. 110 volt, 100, oh, both are same. But when you connect those things, it will spark. Why? It looks same according to voltage. But there is a phase difference, you don't know. Even if you take two wires from one thing, from 0 to 2 wire, I give you, oh, Rana, spark or no? There is no spark means it is same phase. If you take two other phase and try to connect together, it will spark and it will bring a hazard.
Can I give an example for the non-technical people here? Usually the three-phase system is used in the industry, not on the residential building. For example, the elevators or some big machines in the manufacturers.
We use here some two-phase also, or two-phase something. The dryer, you cannot run with the 110 voltage in your house. The dryer needs actually, yeah. And always the motor needs, every motor, most motors, not single phase. Three-phase motor industry, we use three-phase. We use three-phase in residential also. Why?
So now, in your house, 120 is coming in, right?
Always we use what power we take to 220.
So 220 comes into the house?
Yes.
And then it is separated into...
Yes. And you see, two were coming from outside and one 220. It is actually two-phase. Not two-phase, it is single-phase in different way, but it is two-phase. You can consider it two-phase in your house. 240 comes, and what we applied in our cases also, all are two-phase. You see, some BMS sign runs with 240. You know the electronic sign, 240. Most sign is running with 240. So when we apply for the power, they give us 240, then it is split from 110, 110. Actually two-phase. Think it's two-phase, but basically I'll tell you that why it is not two-phase or single-phase they are telling, but the concept is two-phase.
Okay, so how do you transform it? I mean, do you actually use a transformer in your house?
Those slides also, everything. I know that this will come, everything I included in my thing. Those are little things. Technically, you need those things also. It will help your life also easier if you know those basic things. Okay, I have those things also here. It is coming here. And those are very interesting things. If you know all those basics, it will help your life also, always.
Gerald, sorry, another day. Officially in the US, the voltage system is 110, as everybody knows, but practically in the residential homes, I mean, we have 240, sorry, but if you, for example, Rana mentioned the electric guy has a big prong, if you see carefully, and and the thick cable compared with the refrigerator is 110, does not need too much power, I mean. That's the difference. The electric guy has a big prong and the big, outlet, electrical outlet is different from the other device. Because a heavy machine needs a lot of power to dry the clothes in this case.
And also, when you, multi-story apartment, they'll not give you single phase. If you apply for the single phase, they'll not give you. You have to take three phase for the, so why? They use, when it comes, they use a different, apartment, the different phases. They have to balance out those things. If you don't balance three phase, and if you apply, for your residence, you need 100 amps, 200 amps, take single phase. But big apartment, if you apply for single phase, no, they'll not give you. For certain amps or certain rating, they'll give you, provide you single phase. But for huge rating, huge building, you have to take the three phase, and you have to design, distribute those three phase, balance out in your building. This apartment, this phase, this apartment, this phase, this apartment, otherwise you can. And three phase balance system is very, very important. And if it is unbalanced, total system will be disrupted in the whole the country. Every place we use three phase, and I'll tell you those things a little bit also. And I'll tell you very interesting thing with the three phase system. In three phase system, why we need in the industry, it turns on the motor, it runs the motor. How it runs the motor? When you explain the transformer thing, you understand. When you feed three phase in a motor, see, in a motor, you see there is a core and there is a, what do you call? Stator and rotor actually. Stator means the outside, the rotor is internal thing. Okay. When you feed three phase, what happens? Actually, internally, inside there is a coil. Three phase, three coils. When you feed this thing, what happens? A revolving electromagnetic field creates inside this coil. When you feed three phase, this is an interesting case, the magnetic field. So you know that if I give you one iron piece, I tell you to make it magnet, you can make it magnet. How? You put some many coils and put it in your power, the iron become electromagnet. You know those concepts also. Very simple concept. If I tell you that make one iron core a magnet, you just coil up some cable and put it in power, it become magnet. So when three phase goes in the motor stator, it creates rotating magnetic field. If you do not put a stator, if you put any iron, it will attract. So it rotates, and frequency of the rotation, how it rotates, it is called M is equal to X, 100 F by P, frequency divided by pole, number of pole, how many poles. It is different thing, but then when they put stator, it tries to rotate this stator. So this is the actual basic concept of the motor. When you feed three phase, there is a rotating magnetic field, and you put rotor here, it's the iron core, and it tries to pull it, and the motor started rotating. It is for single phase. Now, for three phase, in single phase motor, you always need to rotate something, at least two phase. Without two phase, you cannot rotate anything. So, how fan works in single phase? In each fan or each single phase motor, you will find a capacitor. I believe everybody sees this thing, a capacitor. A capacitor in a fan or in a single phase motor. What is that? Why we use capacitor? Capacitor makes single phase, two phase. When you put a capacitor, one goes this way, another is another phase. When you put any capacitor, it split the one phase to 90-degree angle, another phase. So in any single phase machine, you will find capacitor.
I think you lost your audience to that fire.
Yeah, sorry. There's a call fire, sorry.
No problem. No problem.
Sorry.
No, it's okay, it's okay. So, single phase and three phase. Now, you see, and this is the basic generator. How we generate power, told this thing. How we generate power. So, when you put AC to iron core, it produces the magnetic field. In opposite way, when you put a magnet and a coil, it gives you same thing, the magnetic field. Opposite way also. So the generator is that concept. We use magnets and coil. When you can generate also current, but this is not huge current. If you take one magnet and a huge coil, and if you move this magnet in between the coil, round of coil, it will generate power. This is the concept of generation, power generation. Same concept used in every places. The coil and the rotating and the moving magnet. If you move it, it will generate. And this way we produce some lights in the bicycle. You know the bicycle, when you rotate, it produces light. Same concept.
Dynamo.
Same concept. So you need magnet and a coil to produce electricity. Okay. When you rotate these things, and it will create the coil will interact with the magnetic flux. There is a flux between North Pole and South Pole. You know, everybody knows that there is a magnetic flux goes between North and South Pole. So when the invisible flux is going between North and South, and when you cut this, cut means with the wire, if you cut those things, it will generate current. This is the basic concept of generation. So this single coil, and it shows how it started rotating from here. It produces, when it goes there, it produces high. When it goes there, one cycle. When you go down here, and that way it generates full electricity. See these things, this simple thing. When it starts from a zero, because it is parallel with the flux. When it cuts the flux, okay, flux is going there. When you rotate it, it cuts. It cuts means it produces electricity. First half. Second half, go there, zero. Now it is parallel, again zero. See, again cuts. It goes here. So these are actually the power produced from a generator. And North Pole and South Pole together we say one pair of poles. One pair. So in generator we use many pairs to increase the frequency. To increase the frequency 60 or 50, you need many poles. If you use many poles, you can create. For this one, you can generate 1 hertz, like 1 hertz. But for more hertz, you need more poles. More pole means here one, inside the generator, they use that concept. So this is the basic concept of electricity. And you see, it shows rotating, and it shows one revolution, how it creates those. And it also shows you the peak one is 100 volt here written, and from here it started. It is from here to here is 360 degrees. 0 degree, 0, 1, 2, 3. When it goes 90 degrees, it is 90 degrees. It is 140, you have 180, again 90, 270, then 360. One revolution is 360 degrees. And there is another concept also very important. This peak voltage. When we measure in a meter, it doesn't give you the peak voltage. It gives you a voltage which is called RMS voltage. What is RMS? If you divide the maximum peak √2, where it comes, we can show you the calculation, but you don't need this. When you measure with the voltmeter, you see the RMS, root mean square voltage. What is root mean? I can explain you later, but I can explain now also, but it is called root mean. It is not peak voltage you are seeing in your meter. Actual peak voltage is more. So it is RMS voltage or current you see in your multimeter. It is not the peak. If you want to make it peak, you have to times it with √2. √2 times your meter reading, it is actual peak reading of your wave, which is coming from the power authority. Okay? This is simple thing. You have to know those things. RMS, root mean square volt, you have to, but basically if you times it with √2, then you can get the peak volt. Peak means this peak voltage. Peak value. See, that's why they calculate it is 100. Peak value is 100. And they multiply it 0.866. Root 2 means 0.866. And they get this is the actual voltage, or this one you get from multimeter. Actually, this is 100 volts, but in the reading you will see 86.6 in your meter. This simple concept, so we'll start, and you saw how the power generation from the, they produce this thing in the hydraulic power system. The water comes here, and there is a rotary coil, there is magnet, and it produces current, and you can get those current from hydraulic power station. Same thing happened with the any turbine station, any coal station. They rotate the turbine, and there is a magnetic coil. Everything is there inside the generator. It produces same thing in your small generator also. When with the diesel or a petrol, you run the generator, small generator in your house. Same thing happens. There is a coil. It rotates with the magnet, and then it produces the power.
Can we produce hydropower by free flow stream?
Yes. 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 We don't need to learn just this is the basic thing, and as I told you, it shows here also. You see, voltage and current difference. You see here. When resistance and inductance, resistance and coil comes, we never say it is resistance. We call it, just remember this is called impedance. See, remember it. If resistance and inductance or capacitance comes together, you will never say it is resistance. It is called impedance. When there is impedance, there should be a difference between the shift. Phase shift means angle difference between voltage and current. You see, voltage and current, there is phase shift. When if there is inductance or capacitance comes with the resistance, it is called impedance. Remember, this is very important term. Just remember. And how we calculate? It is R square. There is a lot of calculation there. How we calculate those things. You don't need to know all those stuff. So this is the transformer thing. As you told, the transformer, what they do, they transform the power from one circuit to another. So see, we call this primary, this secondary coil. Primary coil is where we feed the power, we call this primary, and from where we take the power, we call this secondary. Okay. So what is inside the transformer? Nothing. Just coil and some core, iron core, laminated core. Why laminated? You don't need to know this whole thing. There is some iron core and there is some coil. If you see any transformer, you'll find those things. Any what we use here. So there is a one core and okay. What happened? There is no connection between primary and secondary, but even you are getting power from other side also. This is the interesting part of the transformer. And sometimes you have to know in the field you need this thing, KVA rating, very important, current rating. You need to know this thing. Just focus this thing for the technicians, technical people. So transformer is a two coil thing. There is no connection between two coils, but even though the power is transforming from here to here, the where we feed the power, we call this primary, and from where we take the power, we call this secondary. Okay. So how it is working actually? Same thing, flux. So when you put power in any coil, it produces flux, and this flux is linked with another flux. So there is change in flux. When you make transformer, there should be a change in flux between two coils. If there is no change, there is motion. So you see, there is no motion. How it creates flux? When you put AC voltage, the flux is changing because AC is always changing. So flux is always changing. That means when there is a rate of change of flux, then you can create transformer. Okay, in transformer, if you put DC, you will get nothing. Why? DC is steady. There is no change in the current or voltage. So the flux will not change. From DC, you cannot use transformer. This is the important concept. Because the voltage is steady. There is no frequency in the voltage. In DC, there is no frequency. That means it is not jumping. It is steady. To create transformer, to use transformer, you always, if you say, okay, DC, it is 12 volt, make it 10 volt or 5 volt, use a transformer, no. That's why we purchase some converter when we try to convert those things. We use converter, DC converter, because they convert it from DC to AC and again convert to different voltage. So in DC transformer, you cannot use transformer. And for AC, why? Because the voltage is changing, the changing voltage gives you the changing flux gives you in secondary voltage, so this is called primary secondary. Okay, another important, so you understand that concept of there is two coil in a transformer, one is primary, one is secondary. When you put here voltage, and depending upon your coil, it gives you the voltage, and now I am telling you, see here, this is called primary, secondary. You see here, 1:2, that means if there is 20 turns in the primary, in secondary there is 40 turns. 40 means 1:2. Here is 1, another side is 2. If the turn is here 10, it will become here 2. Okay, if you put 1 volt here, it becomes here 2 volts. According to the turn ratio, the voltage will increase or decrease. Okay, if it is 2 volt here, you will get 4 volt here. So how they create? Only from the coil, turning of the coil. How many turn you have? If you have 10 turn here and 40 turn here, the ratio will be 1:4. If you put 1 volt here, you will get 4 volt here. So you can change your voltage as you want according to the design of the transformer. If you design that way, you can make from 1 volt, you can get 133 kV also. Kilovolt. From 1 volt, you can get it. Okay. Do you know those, back in the days, those television sets, there is a tube called CRT. There is a light goes. The voltage inside those CRT, it is a pan of the electronic pan actually. It is 33 kV. You are getting from 12 volts, they create 33 kV. And in the CRT tube, if somebody put any tester, not go close, he'll be shocked because huge voltage created in the back of the CRT tube. CRT tube means
So,
those tubes.
why is it that if you were to unplug the TV, and then we go in there, you could get
It is shocked. Why? Same thing happens before. The capacitor. There is a capacitor to smooth it. I'll show you one day practically how I create AC to DC. Practically you'll see this thing. DC is smooth. I'll show you next classes practically and show you everything in my screen. And you say you will do at the same time. AC to next class I'll show you practical thing how current look like and how I make AC to DC. Practical. You will do it with some electronic device. Here I'll do it next time. Next class, practical I will do this thing. Okay. So he's telling me why. Capacitor. Same thing happened with me and Dave Costello. Dave Costello was a field tech here. Once we go in a sign, it is called PBMS sign for AMRIS, no not AMSIC sign. AMSIC sign, we went there and there is also capacitor. I'll show you a picture. Previous in the power supply, there is big capacitor. And when you turn off the power, he tried to. I said, "Stop! You don't go." And he goes, "No, nothing will happen." When he passed it, he said, "What happened?" I said, "I told you several times, don't touch this thing. There is a capacitor. Capacitor holds the charge for long time. Long time means it is maybe it depends upon the rating of the capacitor. If the rating is huge, it holds the charge for long time. Before you touch the capacitor, don't touch anything. Stop it, wait some time, it gradually decrease the voltage. Otherwise, if you don't want to stop longer time, if it is small capacitor, you have to short those terminals.
You can drain it.
Yeah, drain it. Yeah, you have to do drain it. Yes. This is very important thing. Basic knowledge is very important as an electrical engineer or electrician. If you don't know this thing, you'll be really. And same thing happened to our people also when they go in the battery bank. They see battery banks. There is a lot of batteries. You try to open the terminal with a range, the circuitry. This full solid thing. What happened? When he tried to open this thing, it connect with the negative terminal. What happened? It happens to many people, I know. When I go, I say that, be careful, don't touch this thing. And that's why I told, okay, please order some range with the insulated range. I don't want exposed one. Practically, I face those things. And I saw what happened. We have Anthony Munoz and who?
Tony?
Tony and Stephen Gomez. What they did, they bring some battery from the field, where they put in our inside the TG15 cabinet and put one by one, and they put a steel plate on top of this thing. We are lucky that it doesn't shorted. I say, what you did? No, we secured this thing. I'm telling you, I have a huge experience here. This technician, I know many technicians don't know, have the basics. Okay, I'm not going further. I can stop my presentation here. Next time we'll go. Let's see how many I have here. I believe, yeah, this is important. I'll show you by drawing those things. Very important for, this is the load center. And next time I'll tell you this thing with the drawing and how voltage you can see in your house also. You'll experience those things easily. You can do many things in your house. If somebody says, oh, you have a dryer. One people say, I'll take this much amount, $200, $300 to wiring this thing. I say, forget it. I'll do my wiring. I know how to do this thing. In my house, I did my wiring. You can do something also. You can instruct your people also if you know some basics. They try to play with you. But if you know the little basics, you can solve many things in your house. Definitely. So I'll stop my class here. Next time I'll show you the practical thing, how I make AC to DC, and I'll show you practically how capacitor smooth this thing. It's very interesting. And then I'll explain those things to you, the voltage and the three-phase thing, and it will help you in the practical field and the field also. Because we always use this thing in our power system here also. Okay? So, basic. Thank you very much. So.
Okay, it seems like, if we